Let us learn about time velocity graphs. Acceleration is nothing but rate of change of velocity. We can write it like change in velocity by time. So, slope of velocity time graph will give us acceleration, but area under velocity time graph will give us displacement, that is equal to velocity into time. Let us see an example. In this graph, we can see it is the graph between velocity and time. When velocity was 1 meter per second, when the time was 1 second, its velocity was 1 meter per second. When time was 2 seconds, its velocity was 2 meter per second. And when the time is 3 seconds, its velocity is 3 meter per second. From this graph, we have to calculate acceleration. Acceleration is nothing but slope of the vt graph. So it is y2 minus y1 by x2 minus x1. Let us consider for these 2 points. Y2 is nothing but 3, y1 is 2. 3 minus 2 by x2 is 3, x1 is 2. x2 minus x1, that is equals to 1 meter per second square. Displacement is nothing but area under vt graph, that is velocity into time. Here we have to consider the area under velocity time graph. That is equals to area of triangle OAB. We have to consider this area which is with time. This area we have to consider. Half, base is 3 and height is this 3. We are getting 9 by 2 meters. Let us see some more graphs of velocity and time. In this graph we have velocity and time, and there is a straight line that is parallel to time axis. Straight line parallel to time axis. So we can say slope is 0 because tan 0 is 0. So acceleration is 0. Because slope of velocity time graph is nothing but acceleration, and that is also 0. So we can say if there is no acceleration, then it means velocity is constant. It is moving with a constant velocity. If it is 5 meter per second, then it is 5 meter per second, 5 meter per second everywhere. Suppose it is 5 meter per second, even the time changes 1 second, 2 second, 3 second, but its velocity is not changing. It is remaining the same 5 meter per second. So we can say velocity is constant, so there is no acceleration. Velocity is increasing or decreasing, then we say it is accelerating or decelerating. But here there is no change in velocity, so acceleration is 0. Let us consider this case. Here there is some slope. There is some slope in it. So there is an acceleration present. But here we can see the slope is negative because theta is greater than 90 degrees. So tan theta will be negative. If tan theta is negative, then acceleration is negative. Then it means it is retardation. That is, the velocity is continuously decreasing. That is nothing but deceleration. Let us see this graph. In this graph we can see the graph is not a straight line, but it is a curve. If it is curve, then theta is changing continuously. So tan theta will also be changing. If tan theta changes, slope changes. And slope is nothing but acceleration. So acceleration is also changing. Now let us see the two cases. What if the curve is bending upward and the curve is bending downward? First case, curve is bending upward. In this case, if suppose this is time t1, let us take it as at 2 seconds, and let us take this to be 5 seconds. At 2 seconds, the graph in this graph we can see it is theta 1, and at 5th second in this graph we can see slope is theta 2, tan theta 2, or the angle made by the tangent and time axis is theta 2. We can very well see theta 2 is greater than theta 1. If theta 2 is greater than theta 1, then tan theta 2 is greater than tan theta 1. So acceleration at point B is greater than that of acceleration at point A. That means as the time passes on, acceleration is increasing. So if the slope if the curve is bending upward, we can say acceleration is itself increasing. If suppose there is 5 meter per second square acceleration here, then it can have a 7 meter per second square here. That is what is the meaning of this graph. Let us understand this graph. If the curve is bending downwards, let us see this one. We can see, let us take this to be t1 and let us take this point at t2, or 1 second, 5 seconds let us take. At this point it is theta 1 and at this point it is theta 2. It is nothing but the tangent drawn. So here also we have taken the tangent drawn by this curve and we are taking the time axis. From this graph also we can very well see theta 1 is greater than theta 2, tan theta 1 is greater than tan theta 2. Acceleration at A dash at this point is greater than that of acceleration at this point. Suppose if we are having 10 meter per second square acceleration here, then we must have definitely a lesser acceleration here. Let us take 7 meter per second square. So acceleration is decreasing. So if the curve is bending downwards, then we can say acceleration is itself decreasing. So previously we have seen graph between velocity and time, and what if that was a curve? If velocity time graph, that graph we are obtaining it as a curve, then we have to say acceleration is increasing or acceleration is decreasing. But if displacement time graph is a curve, then we should not talk about acceleration. Then we have to say velocity is increasing or velocity is decreasing. So here tan theta 2 is greater than tan theta 1. So velocity at B is greater than velocity at A. If velocity is increasing, then the motion is accelerated. So from displacement time graph, if it is a curve, then we can say the motion is accelerated or decelerated, or we can say whether velocity is increasing or velocity is decreasing. But previously from velocity time graph, we can even say acceleration is increasing or acceleration is decreasing. But here we can only say whether velocity is increasing or decreasing, whether the motion is accelerated or decelerated.